Welcome to your weekly recording for pre-algebra. We are in the week of January 12th, 2016, and welcome back, or welcome to the second semester of pre-algebra. So in this recording, we are going to review what we did last week and then touch on what you're going to be learning this week. So this is going to be an awesome opportunity to take good notes so that you can understand what we did last week, as well as having notes to use when you go to do your assignments this week. So remember, it is required that you are taking notes while you watch this recording. You also have the opportunity of clicking pause when you need to, so make sure that you're taking advantage of that. You can click pause, take notes, and then when you're ready, you can click play to jump back into the recording. So we're going to start with two warm-up problems, reviewing what we have worked on in the past and what we're doing this week, or that's going to help us for this week. So at this time, I want you to do this these two warm-up problems in your math notebook. I want you to try them on your own first, and then again, go ahead and click pause, and then when you're ready to check your work with mine, you'll go ahead and click play. So the first warm-up problem says the temperature is 13 degrees. If the temperature drops 20 degrees, what is the new temperature? And then the second one, you're just going to evaluate that expression below. So go ahead and click pause now and try those two problems in your math notebook. Alrighty, so looking at number one, the temperature is 13 degrees. We're starting at 13 degrees. Then we're dropping, so we're going to subtract 20 degrees from 13 degrees. What is the new temperature? So if we're at 13 degrees and we drop 20 degrees, we're subtracting 20. That means we're going to be in the negatives because that negative is in front of the bigger number. It's going to be negative what? Negative 7. 20 minus 13 is 7, and this, since the negative is in front of that bigger number, the answer would be negative 7. Then we're going to evaluate this expression below. So let's remember PEMDAS, our order of operations, PEMDAS. It tells us to do what's in parentheses first. The P stands for parentheses. So let's go ahead and do what's in parentheses. 5 minus 7, let's rewrite the equation with evaluating 5 minus 7. 5 minus 7, you're going to get negative 2. And then we still have in the equation negative minus negative 3 times negative 3. And then it tells us E for exponents. Do we have any exponents? No. And then multiplication or division, whatever comes first. As you read the equation from left to right, multiplication or division. We actually have some multiplication. That the set of parentheses here, the negative 3 times negative 3. What do we get when we multiply negative 3 times negative 3? We get positive 9. So now we've got negative 2 plus 9. And what do we get when we combine those two terms? Now we're at the addition or subtraction. Negative 2 plus 9 is going to give us 7. So our final answer here should be 7. All right, so moving on, some reminders. As we start this second semester, a fresh start, make sure you're turning all your assignments in on time so that you don't lose points, and more importantly, that you don't get far behind where it's a struggle to get caught up. And you're constantly playing that catch-up game. If you start on time and finish your assignments on time, you'll be good to go. So make sure you're checking your grades, not only just how you're doing overall in the class, but also how you did on each assignment. So remember, I will grade all your assignments after the due date, and I leave feedback within the assignment. So make sure to read that feedback that you actually click on the assignments, on the graded assignments, to open those up, and that's where you're going to see my feedback. And my feedback is going to help you with redos. Remember, you can redo any assignment except for tests and quizzes. There are no redos on tests or quizzes. But the feedback I'm leaving on your assignments is really going to help with your redos. Do remember, if you do redo anything, that you need to send me a message or email to let me know. Otherwise, I don't know you've done a redo and I won't grade it. Make sure you're also looking at the weekly assignments document. I recommend that you print that out each week. It also has a suggested pacing guide within it of what you should be completing on each day to make sure you're submitting everything on time. So if you print that out, you can leave it next to your computer and cross things out as you complete them throughout the week. Alrighty, so we're going to learn lots of things about exponents this week. And we're also going to look at the different properties of exponents so that we know how to add or multiply, take a power of a power, all these different divide with powers, when we have zero powers, when we have negative powers. We're going to learn all these rules. And some of them are going to be reviewed from last week, but we're going to continually build on our properties and continually use these properties throughout all of this unit that we're working on. So let's jump right in. What is an exponent? What is an exponent? So an exponent is a power. Sometimes we think of it as a power. So here's an example. 3 squared, x cubed, negative 10 to the 100th. An exponent is these numbers that are written above the base number. So we call this the base. So 3, here we'll go ahead and, this is going to be the base, the x, the negative 10. These are all what we call the base. And then that smaller number raised to the upper right-hand side of each number, those are our exponents. These are the exponents. And an exponent tells us how many times to multiply the base number by itself. So let's look at an example. 3 squared. The exponent tells us how many times to multiply the base times itself. So here we've got 3 squared, or 3 to the power of 2. So it tells us we're going to take that base and multiply it by itself 2 times, which would equal 9. 3 squared does not equal 3 times 2. That is not what a power tells us. A power tells us how many times to multiply the base times itself. So in the other example I had was x cubed, so that we would write out as x times x times x. So here it might be better to do parentheses because of all the x's. That's what x cubed means. So an exponent tells us how many times to multiply the base times itself. We can go backwards and we can write a expression using an exponent. So look at number 1. We've got 4 times 4 times 4 times 4. What is our base? Base is the number that's being multiplied by itself, so the base would be 4. How many times do we multiply 4 times itself? 4 times. So the exponent would be 4. So look at number 2. I want you to try this in your math notebook now. How would you write each 2 times 2 times 2 times 2 times 2 times 2 times 2? How would you write that expression using an exponent? Go ahead and try that in your math notebook. So what is the base? And then how many times are you multiplying that base times itself? That will be the exponent. The base is 2, and we multiplied 2 by itself 1, 2, 3, 4, 5, 6, 7 times, so the exponent would be to the 7th power. Number 3, what would that be? How can we rewrite that using an exponent? The base is 7, we're multiplying 7 times itself 3 times, so the exponent would be 3. Okay, I'm going to go into the next slide now, so if you need more time here, go ahead and click pause. Product of powers. Here we've got our first property rule. So when we multiply powers that have the same base, we have a pattern that we use that works every time. So here's the algebraic rule. It'd be like if we had x to the nth power and x to the nth power. So note our bases are both x's, so we've got that same base. So what we would do is you would just take the base and then add the two exponents together. That's the algebraic rule. So let's try it within numbers. So let's say we've got 6 squared plus 5, or 6 to the 5th power. So 6 squared plus 6 to the 5th power. Notice we have the same bases. We've got our bases of 6. We're adding these together. So that means that we are going to add our powers together. So we would just add the powers together to get 6 to the 7th. So now you try. So if we've got 7 squared plus 7 to the 8th power, how can we simplify that? And this is actually, there's a mistake here. These are the products. I'm looking here. Products means multiplication, so this is not being added. These should be being multiplied. When you've got two numbers that are being multiplied, two numbers being multiplied gives you a product. So they should be multiplying, not being added. I thought something looked fishy there. So let's fix all these. So when we multiply, that's what I meant to be saying. When we multiply two numbers that have the same base, that's when you add your exponents. That's when you add your exponents. So make sure you fix that. That should be multiplication. There was an error in there. All right, so now when you multiply two numbers with the same base, you add the exponents together. So we would, since we're multiplying, we add the exponents together. So if we have 7 squared times 7 to the 8th power, how can we simplify that? How can we simplify that expression? Well, the base stays the same, and we add the exponents together. So we're going to add 2 plus 8, which would give us 7 to the 10th. That would be our final answer, 7 to the 10th. The base stays the same, and you add your exponents. So what about number 2? Go ahead and do that one on your own. So if we have 2 squared times 2 to the 3rd, we're going to, our base stays 2, and then we add our exponents together, which would give us 2 to the 5th. Good. So that's when we multiply, not add, multiply powers with the same base. All right, moving on. Power of a product. So here, to find the power of a product, when you're taking a power of two numbers, you need to find the power of each factor. You need to find the power of each factor. So, for example, here's the algebraic, here's the rule. If you have x and n and you're raising both those, they're in parentheses, and we've got an exponent, that means you need to raise each of those variables times n. So you're going to take x to the nth power and y to the n. Each of those will be raised to the nth power. An example with numbers, so we've got 3 times 6 squared. So what we're going to do is we're going to take each term in the parentheses, 3, and square it, and multiply it times 6 and square that. That's how we would rewrite that. So the example below here, we've got two numbers, that dot means multiplication. Take each number in parentheses and raise it to the 2nd power. So we would have 2 squared times 4 squared. Go ahead and try number 2 on your own. You've got two numbers in parentheses with an exponent, so you're gonna take each number and apply that exponent. So when you do that, go ahead and try that. You should have 2 cubed and x cubed. When you've got something raised to the 2nd power, we can say it's squared. When we have something raised to the 3rd power, you can either say to the 3rd power or you can say it's cubed. Okay. Quotient of powers properties. So what happens when we have the same base raised to different exponents and we're dividing the two numbers? So remember when we multiplied bases, same bases with an exponent, we added the exponents. Where now when you're dividing, you're going to subtract. So here, when we're dividing, you're going to subtract the two exponents. That's the difference here, is when we're dividing with the same base, we subtract the exponents. So here, we've got 7 to the 6th power over 7 to the 2nd power, or 7 squared. So to solve this one, we're going to take the base, it's the same, and we're going to subtract the two exponents. So now we'll get 7, 6 minus 4 is 4. So 7 is to the 4th power. That would be our answer. So how I'm going to give you one to try on your own now. How about 8 to the -1 over 8 to the -6. So don't let the negatives mess you up. You're still subtracting the two, so be careful with this one. So go ahead and try this one. So just watch your negatives. Watch your negatives. All right, we would have this, write the same base. We take -1 minus -6. So what happens when we have a double negative between two numbers? It becomes a plus sign. So what's -1 plus 6? It would be 5. I'm going to go on the next slide, so go ahead and make sure you take notes here. So if you need to, go ahead and click pause. All right, let's combine everything we've learned so far. Let's combine everything we've learned so far. The directions say evaluate, write your answer as a power. So we want to leave our answer as a power. So that, remember that dot means multiplication. So really what we're doing is we're multiplying these two fractions times each other. So we're multiplying x⁵ over x squared times x to the 7th over x squared. So using PEMDAS, you're going to multiply or divide as you go from right to left. So I'm going to multiply what I'm going to do is I'm going to multiply the numerators together. That's what I'm going to do first. I'm going to multiply these two numerators together, and then I'm going to multiply the two denominators together. That's going to be my first step. So when I multiply my two numerators together, I'm going to have x, and then remember, what do I do when I multiply? I add the exponents. And then same with the denominator. I have a base of x, x squared times x squared. I'm going to add the exponents. So then I'm going to go ahead now and simplify both the numerator and the denominator. What do we get? x7 plus 5 is 12. And then our denominator is really x to the 4th power. Am I done? No. Now I can use my quotient property of powers. So when I'm dividing two numbers that have the same base, remember what I do? I subtract. Yes, you subtract the exponents. So 12 minus 4 is 8. So our final answer would be x to the 8th power. So again, review what I did here is first I multiplied my numerators together to get x to the 12th, and I multiplied my denominators together, x to the 4th. Then I had a division problem going on here, where I know when I use division and I have the same bases, I have to subtract my exponents to give me x to the 8th. All right, so look at number 2. We've got 3 to the 10th over 3 squared times 3 to the 3rd. So what are we going to do first? Let's simplify that denominator. Let's go ahead and simplify that denominator. We've got some multiplication going on in our denominator that I want to simplify. So I'm going to keep the top as 3 to the 10th, but how am I going to simplify this denominator? They're being multiplied. So when they're multiplied, we take the base and then we add our exponents. So 3 squared plus, so 3 cubed. So we're adding the 3 plus the 2 gives us 3 to the 5th. Okay, so now we've got a division problem. And what do we do with our exponents when we're dividing? We subtract them. So we'd have 3 10 minus 5, which is the same as 3 to the 5th. That's our final answer. So I had to multiply, I had to simplify my denominator before I could put then the numerator and the denominator together. I'm going to go to the next slide, so make sure you take notes. You will see problems like this in your homework this week. Negative exponents. So if you ever have a negative exponent, you can rewrite the expression to make your exponent positive. And the way to do that, so if you've got a negative exponent like negative n, if we flip it to its reciprocal, the power will become positive. So here's an example. If we've got 4 to the negative 3, remember we can flip it upside down into its reciprocal, and that's just flipping a number upside down. Remember, every number is written over 1. We just don't have to say that. Any number divided by 1 is going to equal itself. So to write this and make it a positive exponent, we just flip it over and then it becomes positive. Another example, 2 to the negative 6, if we want to rewrite that with a positive exponent, we would just flip it upside down to its reciprocal, 1 over 2 to the 6, and now it's positive. I'm going to go to the next slide. Go ahead and click pause if you need more time. 0 power. Any number to the 0th power is going to be 1. Besides 0, any number besides 0 raised to the 0th power is going to be 1. You can't take 0 to 0, so that's why that's not in there. So any number to the 0th power is always going to be 1. 5 to the 0th power is going to be 1. The power of 0 to 0 is undefined. You can't do it. Try plugging it into a calculator and it's going to tell you error. So any number, it could be 100 to the 0th power. It'll be 1. It could be negative 636 to the 0th power. It's going to be 1. Anything raised to the 0th power is going to be 1. I'm going to the next slide now. Let's combine it all again. Let's combine everything again. All right, so here we go. What do we do here? We've got some division going on. So what are we going to have if we have, you know what, I'm going to, I don't like this problem the way it is. Let's do, what do we want? I'm going to skip that first one. Let's do number 2. Let's just do number 2. So we've got some division going on, right? So let's take care of the division first. So the 4 is going to stay outside. There's no parentheses around it, so it's not raised to the negative 2. There's no parentheses around it, so we're going to leave it alone. We do have some division. We've got y, and we're dividing, so we're going to subtract the exponents. Negative 2 minus 4. And what do we get? We're going to get 4. Negative 2 minus 4 gives us negative 6. If I wanted to rewrite this so that it has a positive exponent, how can I do that? We always like to have positive exponents. We only want to flip the exponent, the base and the exponent will go on the denominator. Only the y, the 4, is going to stay on the top. The y to the negative 6 will go down on the bottom. And I think that's what, let's see what happens at this top one. I think that's a similar idea here. So let's look at the problem on the top. Again, we've got some division going on. We've got the x to the 3rd divided by y to the 6th. So that's going to become x, 3 minus 6. 3 minus 6 is negative 3, and then that 4 is going to stay on the bottom. Now, how do we make that negative exponent become positive? We're going to throw it on the bottom. We're going to say 1 over 4x to the 3rd. I had to put a 1 there because, remember, x to the negative 3 is really over 1. So we're going to put that 1 on the top. And that's that. So I'm going to go to the next slide and wrap up. all the things that we learned about today. We learned about what an exponent is and what a base is. 3 squared equals 3 times 3 equals 9. It is not 3 times 2. We learned about the product of powers, where we add our exponents together. Power of a power. Oh, we didn't do power of a power. Somehow I skipped that. Power of a power is like this. 3 squared to the third. So that is when you, power of power, you multiply your exponents together. So we would take, instead of adding them, it would be 3 times 2, which is 6. Another example would be like 2 to the 4th power squared, which would be 2 to the 8th. So that's a power of a power. Somehow that got left out. We did power of a product, where we subtract our exponents. We did quotient of a power. Whoops, that's where we subtract. That's got scooped. And then anything to the 0th power is always going to be 1. And then to get a negative power to turn positive, we just flip it upside down. All right, so we are ready for the 112, the week of 112, not 1-3, key phrase assignment. So I want you to tell me how to simplify, which means you're going to write your answer as a power. You're going to simplify. You're going to write your answer as a power. You're going to write your answer as a power. How to simplify x to the 10th over x squared. How can you simplify that? That is your key phrase assignment. I've got the directions on how to complete the key phrase assignment. This is how you get your credit for watching this recording. You have to complete the key phrase assignments to get your 10 points for watching the recording. The directions are below if you need a review. You'll log into Pre-Algebra, you'll click on the materials folder, you'll click on the week of, you'll go into the weekly recordings folder, and then you'll find this assignment and you'll complete it. So let me know if you have any questions as you're watching the recording, or if you have any questions while you're working on this week's assignment. That is a wrap.